Hi, in this video we will discuss about case study 3. The case study 3 is covering chapter 2 about stress concentration. Case study 3. In this problem, we asked to analyze a hole has a diameter of 9 mm and we need to determine the radius of the fillet for which the same maximum stress occurs at the hole A and at the fillet. And the other one is we need to determine the corresponding maximum allowable load P if the allowable stress is 100 megapascal. To answer this kind of problem, we need to list all of the known for this question. We have R is 4.5 mm and P allowable is 100 megapascal. Then we need to calculate the 2R over T, and then we obtain the 0.09375 millimeter. And why we need this one? Because by this equation we can see to the figure 2.52a and we can find the constant for stress concentration in this hole. From this graphic we will know that we obtain 2.72 as the constant. Then, by using this formula, where the maximum stress is equal to the constant for the stress concentration times by applied load P over the net area. And then we need to then find the A net in this system because we have the maximum stress and we have obtained the K hole in the system. The A net is obtained by multiple the d, the smaller d, times by t, and the smaller d actually is this area where the 69 minus the diameter of the hole. So we will get 87 millimeter as the smaller d and it times by the thickness 9 millimeter. After it, we will get the P hole or the P applied in the system, the maximum P, which is 28.79 kilonewton. After finding the maximum force applied in the hole, we need to determine the radius of the fillet, and we list all of the known in the fillet. We have the bigger D 96 mm and then smaller D 60 mm, and the maximum stress is still same 100 MPa. And from the question we need to find the radius of the fillet where the P hole is equal to P fillet, so we can assume that the P hole and P fillet is the same. Then maximum stress is the same thing, same as the formula before, but now we use the A min. This A min actually is directed to this part where we have the smaller t times the t, so we choose the minimum area because as with the same amount of p but with the smaller area the stress is getting bigger, so that's why we choose the A min using the smaller t times the t. So from this equation we will obtain the K fillet. There's A min times the maximum stress all over the P hole, and the K fillet that we obtain is 1.88. The K fillet that we obtained before is 1.88. Then to find the radius of the fillet, we need to look at the feature 2.52b. But by knowing the K only, we can't directly find the radius of the fillet, we need to find one another parameter, which is the bigger d over the smaller d. So we need to calculate it first. For this question, the d over the smaller d is 1.6. We go to the bottom and we obtain the RF over d, which is 0.19. Then from this one we just obtain the radius of the fillet, 0.19 times by 60, and we get 11.4 millimeter.